Hey Tim, how are you?
I'm great. How are you?
Thanks for coming.
Welcome.
For Level Up Geo, and why don't a bit of a background and history about yourself?
Okay, so I actually joined forces with Damien back in 2007. I was running my own company, and
You guys belong in the museum, but
yeah.
in internet time.
They had to subcontract because they had a lot of work at the time. So my company was helping out, and I got introduced to some larger scoped geo work at that time. Before then, I had dabbled in Google Maps, and it was quite fun. But at that point is when I really started to discover the joy, I suppose, of working with data and pushing it onto a map and making it do lots of different things. So over the years, I worked a lot with Damien. Then in, 2011, I came here. 2011, at the end of 2011, and I was back and forth to Australia a little bit.
It's a bit of a cheating thing, isn't it? Because you guys came from Australia, which is like a bloody continent, with a lot more space and mapping stuff, and then you guys figure it out how to do things there, and then you're like, okay, we're gonna come to KL now and Malaysia, and it's like, like what, 1/10 the size?
Yeah.
It's a bit cheating. Like whatever solution that you guys have made in Australia, like, oh yeah,
But what you gotta understand is that most of Australia is empty, right?
What is the
coastline?
Yeah. What would you be, say, the most proud solution that you've had come up with in terms of your career? Yeah.
The most proud solution. In
terms of geo.
That's a tough one because I've worked on so many solutions, but I guess as a whole, the platform itself, GeoMash. I mean, that's something that I've been working on for a great many years. We're currently working on version 4 of our platform, and I started when version 2 was being developed.
Okay.
So it's come a long way since then. It's like one of my babies, and I've seen that roll into many different products and solutions as a platform. So
if I brought my auntie, who's like, she's savvy with smartphones and whatever it is, but if she asks you like, hey, what does GeoMash do? What would be the one-line thing that you would tell my old auntie?
Puts data on a map. Okay, or if it's your auntie, you could say it tells you where you parked your car.
Cool. Okay.
Hopefully a bit more than that.
What will your talk be about tonight?
Okay, so
sharing? Yeah.
My talk's all about the data and how you can optimally display that on a map. So quite often we come across scenarios where we'll consult for some other job and they'll be like, look at our map. We have a couple of thousand points on there, and it's growing day by day, a couple hundred every day, and it's a mess. So we go in there and we say, okay, well, you've got to do this to your data, or you've got to display it in this way, and you've got to optimize your code in this way to be able to get better performance from your displaying your map for people using your maps. So that's what my presentation is all about.
So you're hoping to, what type of attendees or people are you hoping to?
This is very much for the developers.
This is very much for the developers?
And I suppose the analytics guys.
Do they need to have an A in geography?
No, not at all. I mean, this is part of the problem because they have a lot of developers who aren't so experienced with geo.
Yeah, and spatial and
exactly. So
like myself, I'm a designer.
They get a scope of work. They say, okay, I need to display all these points on a map, and they just do it. There's no other thought involved, and then they realize, but it's really slow. How do I make it better?
Cool.
So this is what I'm trying to help to alleviate.
So what do you think right now? Again, because you're going to be appealing to developers, maybe just a bit of sharing. What do you think right now is the biggest challenge in terms of a problem that's still looking for a solution in geo, in your personal opinion?
The biggest challenge?
Yeah. The tricky, in terms of your understanding of the technology and the platform and the limitation, what is the next big thing that geo needs to solve?
That's a hard question.
I can solve anything.
I mean, day by day we get challenges with geo. We take them one at a time. But I guess one of the biggest issues that I have is the open knowledge of geo. Quite often I'll have to do something new I've never done before, and I'll have to research and Google it. But there's not a lot of knowledge, so you have to go to specific info groups and things like that. if there was a greater open geo world, then there would be a lot more geo developers and a lot more knowledge on how to do that sort of thing.
Why do you think that is? I mean, why is it that, like you say, that we need more geo developers, but there's not? Why is that?
There's not enough awareness for starters. I mean, there are open products. You've got OpenStreetMaps, you've got open layers, but how often do you see an OpenStreetMap used on the internet? You always see the Google Maps.
Yeah.
There's too many mainstream things going on, and we have to change that. So with open data and open maps and that sort of thing.
I think one of the challenges, and maybe here is also something that's trying to resolve that as well, is that you have all this data, all this available geo data. It's quite clunky when you have a one-stop platform where, like, I tried opening Google Maps layers. It's a lot of stuff. It's just too much things. I mean, yes, you are aggregating all that stuff.
Yes.
But there's no utility out of that, and then I think that's where you all come into play, because you are trying to find that that utility out of all that data.
That's right, and the other thing is when you have your own data, you have a Mammoth Oracle database, for example. How do you get all that data onto a map? The fact is that maybe 90% of data is mappable, right? But no one knows how to do it. Well, there are obviously people who know how to do it, but there's not enough open knowledge to know how to put it onto a map.
You're right. Like even like today, right now, like Google Maps, I'm still struggling to how do I drop a pin and share that pin?
Yeah.
That's crazy. I'm like, this shouldn't be so hard.
Yeah, but particularly when people put the address as off Jalan Klang Lama, around the corner from KFC under the bridge.
Yeah.
How do we geocode that?
Yeah. Do you think that altimeters could change things? Because right now, our smartphones have got all sorts of things.
Well, I'm not sure. I mean, we've seen the smartphones do the smart data, and we've seen the disasters that come out of that. I won't name names, Apple, but that being said, it does get improved. So I don't know. It's yet to be seen. It's yet to be proven to actually be a big success or not. Yeah.
Okay. One last question for all you guys. What exciting thing? Hopefully you can share this, and I don't need to sign any, and nobody's signing any NDAs. What is the next exciting thing that you are working on or thinking about right now?
The next exciting thing. Well, I mentioned that we're building a new version of our platform.
Yeah.
So we're actually using a lot of new technologies, a lot of which we're building ourselves. Some are proprietary. Some will be shared open source.
Okay.
So
what's that one thing that makes you go like, yeah?
It's the end goal, which was the dream at the beginning when we started GeoMash. It's the ability for anybody off the street to come in and follow a simple wizard to create a map with all their data. So that's currently what we're going to be pushing out into.
So what would be a potential use case for old auntie? Like, what can I do with you? She likes eating out.
Likes eating
out.
Okay,
yes.
So maybe she has an app that we could roll out an app which records her favorite places where she's gone, and tracks that on a map on a weekly basis. So be able to publish that data from our phone into a data store of ours and easily publish that to her friends or
putting you in a spot because it's very hard sometimes.
That would be a great service for marriages. How many times are you sitting there at night with your wife or your husband respectively and saying, what's for dinner?
Yeah.
I don't know, what do you want? What do you want? What about an app that knows where you are, where you like to eat, and just make suggestions,
Exactly, yeah.
And basically tells you, you haven't been to this one for a long time. That's the one that you should
That
go
sounds
to.
good, let's go there.
Yeah, cool.
Yeah.
And what about you?
Okay, you heard
as a sales guy, but
I mean, globally, there's no secret. Globally, customers like Linda, they've been talking about driverless.
Driverless.
Yes, technology. So
you guys are all ready
to get driverless. You need precise data. So this is where we will come in. So later, when in my presentation, I will show you the video how we're collecting all this precise data moving forward. Because for them to launch 5 years down the road, they need to start talking about it today.
So will you buy a driverless car? Will you have exclusive access to get a driverless car before everybody else?
No.
but you're freaking here.
Yes, but we
you need to beta test.
Definitely. We will definitely test it on their behalf. But then I will not get it first.
There's a vote of confidence for your own technology.
Yeah. Okay. And yours?
Well, for me,
Lucky last.
commercially, one of the things that we're going to announce tonight is our new public interest portal campaign, where we're going to be giving away a lot of technology to interest groups and anything that we think is going to be cool.
Mm-hmm.
But technically, the big thing for me that's exciting at the moment is, for a long time we've been talking about true ubiquity when it comes to choosing your map for our platform. Traditionally, you've had to be either a Google customer or a Here customer or a Bing customer, and what we want to do is do away with that and basically say our platform and our technology is completely abstracted from the underlying map. So at the press of a button, without rewriting any code, you can swap from being a Google customer to being a Nokia customer, which everyone should do. And that's really exciting.
Cool. So we got 3 of you guys giving talks, and then we've got Z, who is a GIS guy, and he's actually off site right now. He is going to try to get a recorded presentation for us. He actually wants to share about how do you get geo data in a off the grid thing. Basically, he's in a lonely island somewhere, apparently getting ready for a bikini shoot, and he's supposed to get apparently what he shared was that using walkie-talkies to triangulate their exact positions on an island, and being on an island and tropical storms and stuff, GPS may not be there. So how do you get that sorted out? I hope we can get that. I hope we can get that presentation for us. And then we got Jeannie Wong. She's an iOS developer. She basically is giving an interesting twist to geo and location. She's talking about developing on iBeacon. So the proximity sensor device is kind of location based, but you don't need any,
Yeah, I mean, you'd be surprised how many people come to us for indoor location.
Yeah.
If it's an airport or a shopping centre or a school complex, I mean, if you're indoors and you're surrounded by concrete, how do you use GPS? So I'm looking forward to that one.
Yeah, but to manage your expectation, I don't think she's going to be talking so much about that kind of like meshing kind of thing.
Yeah.
But it's more like, when people think geo, the bare minimum even for a retailer is just, I just want to have an ability to be able to say how many customers come into my shop.
Okay.
And what happens is you have a device, and then you basically tell the device you are here. And then you'll be able to start streaming data and say, anybody, all the devices or whatever that tracks there are there.
Right. Yeah.
Without having to, because if you think about it, right, you can say, I'll put a GPS tracker in every merchandise, but that doesn't make sense. But if I have just a proximity thing, and then you'll be able to, track flow and stuff and so on. So I think she's more covering that kind of area.
Okay,
but
cool.
Indoor tracking, indoor locating, I was trying to get somebody, but apparently NDAs are in the way. So sad but true. So apparently that's a really hot space right now.
Were you trying to get someone from Google for that?
Yes, I did, and I got slapped by NDAs. So never mind. Maybe you can touch a bit about
Sure.
Maybe you can touch a little bit about indoor. I really tried to find somebody to come and share what is the bleeding edge in indoor mapping, but apparently that is like I probably get better luck getting NSA agents to come and share what they know.
Well, I can cover that a bit for you.
And Roslan, he used to be doing a lot of stuff, and then now he's doing this little pet project that requires geo, just a simple application of geo. I have a feeling that maybe after he shares what he's doing, I think you guys should really chat with him and find out how to empower him even more. I'm not going to spoil it for you guys, but you probably want to. He's lucky last, so you guys stay for that. Are we good? All right. So if you're still wondering whether you want to come for LVL.UP KL tonight, geo and location services, we are covering the depth and breadth of things. We got calling all the way from Singapore. Hopefully selling you here. And if you bought here and you don't know what to do with it, we got these 2 guys to come and advise and consult you on a possible solution to help geo-enable your business or whatever it is. Thank you. See you guys.
See you tonight.
Tim from GeoMash.
Thank you.
What's so fancy?
Can you reload it?
Reload it.
Reload the page.
You guys introduce yourself?
Okay, thank you. So first of all, who's paying attention? Not you. Anyone else? Over here? More later. All right, now that I've got your attention. Yeah. Okay, so I'm going to be talking about optimizing your maps. So it's more about being able to take the data you have, clean it up, make good fresh data, and being able to make it more presentable for your end users. So firstly, a little bit about me. I'm the director of GeoMash. By day, I am mostly an engineer, and I do most of the work on the I've done most of the work on the GeoMash application, and in recent years we've taken on a fairly mid-sized team, and they've also put in quite a bit of work into the platform as well. So I started with Damien on the product back in 2007, and we've gone through quite a few iterations, and it's been a hell of a ride. So I've been here since 2011, where I had a few brief visits to KL, and eventually Damien didn't let me come back to Australia. So I've been stuck here ever since. All right, now let's get into the guts of the presentation. So I'm here to teach you about all the things. So we're going to be covering point clustering, polygon simplification, custom tile servers, and we'll take a brief look at TopoJSON and a few different rendering engines that you can use. All right, so point clustering. First of all, what is it? Well, a lot of the times you will see maps like this. And quite often I find this happens for two reasons. First of all, it could be the fact that the developers, they don't have the bigger picture. They don't have the big scope, or they're lazy. So one of them things happens, and then you end up with a mess. Perhaps the map begins with a couple hundred points. The product is deployed, and over time it turns into thousands, hundreds of thousands, and then you end up with a mess, which is pretty much just meaningless information. You can't really get what you want. You can't accurately click on a point and say, what is this? And get an answer. So what do? We cluster them. So clustering is a technique which is not really used enough, but I'm seeing it used more and more. And essentially it takes a group of points and groups them together based on their geometry. Now there's quite a few algorithms out there. At GeoMash we use our own proprietary one. But commonly you'll see ones like the k-means clustering techniques. And it's essentially just a way of load balancing points into different groups and trying to space them apart so that they're not too close to other groups. So essentially what happens is you end up being able to click on a point and get a breakdown of those points. Now when I do this, there could be another set of clusters, which are smaller clusters, and I could keep zooming down until eventually there's either singular points or the map can't cope with zooming in any further. So in the latter scenario, generally what we do is we have what's called a special cluster or a supercluster, where you click it and it has detailed information about all the things at that particular location, which differs from a generic cluster which generally just zooms in. All right? So, now that we know what it is, why should we use it? Well, obviously it reduces clutter. You've seen that with that simple demo. However, it's also beneficial for performance. So based on the number of points that you're adding to a map, eventually it gets to a point where you can't render more without crashing the browser. Or it's so slow that you can't pan around the map. It's jittery and it's slow, and then you get those awful pop-ups from your browser which says the script is running too slowly, would you like to abort? That's a terrible user experience, and you never want your users to see that. So we flip this on its head and we end up with something like this. as you can see, eventually you get to a point where no matter how many more points you add into the clusters, it doesn't affect the performance because you can't have any more clusters. The algorithm takes care of it and caps it out. Various algorithms you can set a cap so that it would guarantee that there's maybe only about 100 clusters shown, and others just are more generic where they just try and show as many clusters as they can. All right, so how do we use it? There are a number of ways we can use it, but in terms of a demo that I like to show you that you can actually grab at home and try out yourself, this is one that uses Google Maps. I'm not sure if I can... Prezi didn't turn them into links. Hold on a sec. Oh, it did. There you go. Okay, so here's a simple demo of clustering. So if I zoom out, okay, internet. It's a little bit slow. All right, let's zoom in then. All right, you see it starts to break down. So different clusters of different sizes have different colors. I mean, you can do anything, really. It's just the way you code it. So zooming in breaks down further, until eventually we're at single points. Oh, this one's really close. There we go. All right. So this is, you can grab my slides later. It's all online. You can have a look at this for yourself. This is an open source clustering algorithm for Google Maps. If you want one for here, maybe I can get one off of the Nokia guys later and put it on the Facebook group. All right. Okay, let's move on. Polygon simplification. So, polygon simplification is the way which we turn complex polygons into simpler ones. So, what we have is a polygon which perhaps could have hundreds, if not thousands, of points. So we just spoke about clustering points. What you got to understand is when you render a polygon onto a map, there are still points there. Yes, it's a shape, but every point, every intersection of the shape is a point. So in something like this, there could very well be hundreds of points. The more polygons you add to the map, the slower it's going to render. You're going to have the same performance problem as when you don't cluster. So what we do is we transform it into something like this. So a simplification algorithm will try and find points between points and eliminate them, or trying to maintain some form of shape. So why do we use it? Well, it's all about performance. So based on the number of polygons you have, the rendering time increases. Now, as you increase the level of polygon simplification, the rendering time reduces. However, what you'll find is you get to a point where your good rendering time, that's in green, is meaningless. You end up with shapes that are squares or even triangles, which don't even closely represent what your original polygon was. So you want to find a middle ground, which is somewhere in the middle, right there in the yellow. That's still not ideal. It's still very slow. So polygon simplification, while it's good in some scenarios, is not great for every scenario. But how do we use it? Okay, so there are actually a lot of libraries out there that you can find. Just Google for polygon simplification. Most use the Douglas-Puka algorithm, which is a commonly implemented one in most languages. Here's a screenshot of another simplification. I think I can zoom in. There we go. All right, so there's a bit of an idea of what happens with the process. All right, and you can check that link in your own time. All right, so to fix the polygon simplification rendering time issue, we simply don't render polygons. Not in their true sense anyway. We switch to something like custom tile servers. So, what we end up with is a grid. This is your typical map. It has nothing on it. It's just a bunch of grids, and you load different layers. So you might load a layer from Google or Nokia or OpenStreetMaps. You might load the satellite view or the terrain view. These are all just mapping layers that are coming out of GIS engines. So here's a Nokia layer that I've loaded. Still got the grid in effect. But then what we do is we load another mapping layer, which is just the polygons pre-rendered. So in this example, there's a bunch of polygons. This is just rendering them in little chunks, as you can see with the squares. So this will pretty much load as fast as a normal map layer would load. All right, so we can see that here. So as we saw in the last example, the number of points in a polygon without, and then it's pretty much a flat line if you are rendering with tiles, right? So it's a huge benefit. You don't get that middle area where it starts to fail, where your polygons look stupid. You've just got pre-rendered polygons. They load fast because they're just images in a browser. All right. Now there's actually a lot of solutions out there. I think I had some good examples. Try loading these up. Yeah, so there's Dora, which is a program which will allow you to inject imagery, and it'll slice them all up for you, and then you can pretty much just use some sort of URL pattern to load the images. All right, there's a couple others. They're pretty much exactly the same. It's mostly just information if you want to get into that yourself. You can check out the slides later. Okay, so getting to the tail end of my presentation, there's a couple other techniques that I would like to touch on. The first one is TopJSON. So essentially it's topology GeoJSON. Now who has familiarity, or who knows what GeoJSON is here? Yeah, a couple of you. Essentially it's a way to store geometry data as JSON. It's a standard format which the community has created and published, and it started to be implemented in a wide variety of systems. At GeoMash, we use it for everything in our platform, and we store it all in MongoDB, which has native support for it. So the topology side, essentially what it allows you to do is, imagine you have country states, and you wanted to store them as detailed polygons. Now, if you had two polygons next to each other, their borders would overlap. So you'd have duplicate points. So what this does is it creates arcs and stitches them together. So they're essentially arcs of polylines. And what it allows you to do is stitch them so that you're not duplicating the points or the lines. So that's another thing to look into. It's reasonably new. Unfortunately, it's not natively supported in Mongo yet. So we ourselves don't use it, but we'd like to. So the final point is rendering engines. So you all know the traditional Google Maps, old school, render a bunch of images in divs and display them and clutter your DOM and all that sort of stuff, right? It's really slow, and it actually brings your browser down. There are solutions for SVG. Similar issues with the DOM pollution. However, it is significantly faster to render. I might bring up some of these as examples, actually. Okay. So this one's an SVG map. So it's quite snappy, but the internet connection's a little bit slow, but performance-wise, it's really good. All right. Now, the other one didn't open. Okay, so this is an OpenLayers 3 example of Canvas. So Canvas is another HTML5 technology which greatly improves rendering imagery in your browser. All right, so this greatly reduces the amount of DOM elements in your page, and the performance is really good. You should try this one out. Lastly, and the best performance is WebGL, which I've copied the same link for. Apologies for that. Right, so who's heard of Cesium? So Cesium is a new 3D mapping technology which is WebGL based. So I'll load up a cool demo. So this is loading a bunch of satellites around the Earth, rendering them in WebGL. So 3D at your fingertips. Each one of these has details. You can click on them and got a timeline that you can drag forward and whatnot. So yeah, that's a quick look at WebGL. So you can also use that on 2D maps. So we use that a little bit ourselves. The support's still pretty new, so it's taking a bit of getting used to. But the performance is by far the best because obviously it's using your native computer's graphics card. There's nothing emulated. All right. And that's it. Thank you.